Hello! Today we are looking at the very important algebra skill of factorising quadratics. In this specific video, we're only going to be looking at the basics behind factorising quadratics, and then we'll have another separate video looking at some special tips and tricks for some very specific scenarios involving quadratics, and then we'll also have some other separate videos that focus on actually using the factorising to help you solve a quadratic, and even a video looking at factorising things that aren't quadratics directly. So with all that said, let's get on with it. So first of all, let's look at actually what is factorising and why do we care about it. Because interestingly, a lot of the algebra actions we can do are things that do relate to things that we can do with numbers, and I feel a lot of students lose sight of that, and therefore that's what leads them to doing illegal algebra moves they're not allowed to do because they don't understand what's actually going on. The word factorising is related to the word factor, and you might remember that a factor is a number that another number can be divided by nicely. So for instance, if we have the number 6, it's got the factors 1, 2, 3, and 6, because those are the only numbers that you can divide 6 by nicely. But then if you want to factorise something, what you're doing is you're expressing that original number as a product of some of its factors. And the word product means multiply, so basically you're taking some of its factors and multiplying them together to get the original number. So for instance, 6 can be expressed as 2 times by 3, because 2 times by 3 is equal to 6. That's all factorising is doing. It's just doing that with algebra. So you're taking an algebra expression and you're pointing out what other bits of algebra can be multiplied together to get your overall bit of algebra. So for instance, x plus 2 times by x plus 1 is what gets you x squared plus 3x plus 2 if you were to fully multiply those brackets. But it's still this idea of something being multiplied by something else, in other words factors, to get the original thing you had. Cool, but why do we care about factorising? Well, it's worth pointing out it's important for both solving equations and also it's useful for simplifying algebra fractions. So we'll look at actually applying that idea to those concepts in some other videos, but it's always good to have in your mind an idea of why we do these things. The last thing I'd like to point out before we actually get stuck into an example is that factorising is an example of algebra rewriting. All you're doing is you're changing, when you factorise something, you're changing how it looks, but you're not changing the algebra value of what is there. By that I mean you could plug any value of x you like into the algebra before you factorise, then plug that same value of x into the algebra that you got after you've factorised, and you should get the same number out of both of those expressions. If you don't, you have factorised it incorrectly. It's worth mentioning that algebra rewriting and algebra simplification are all under the same banner as each other. They all have the same rules, different to the rules we're allowed to do when rearranging and solving equations. I'll have another video based on that to sort of explain the differences between them and what you are and aren't allowed to do in a future video, but for now, just to make you aware what sort of category factorising sits in. Okay, let's start by having a go at actually factorising a quadratic, and we'll start with the simple stuff. We'll look at quadratics that only have one lot of x squared in them. That means you've got the quadratic where there doesn't appear to be a number in front of the x squared, what we call a coefficient, and that's therefore just naturally telling you you've just got one lot of that thing. So if you're doing that, what you need to do is you need to look for two numbers that multiply together to make the constant term. That's the number that's on the very end with no algebra attached to it. But also, those two numbers also need to add together to make the coefficient of x. That means the number in front of the x term. Okay, let's look at an example. So with this situation, we are therefore looking for two numbers that multiply together to make positive 6. And then we're also looking for two numbers that add together to make positive 5. So a little tip and trick is that it's easier to start by thinking about the numbers that multiply, because there are less factors for numbers than numbers that add together to make another number. So it's easier to narrow it down by starting to think about what numbers multiply to make the number you're looking for. So therefore, if we're thinking about 6, there's only two pairs of options, 2 and 3 multiplied together make 6, and 1 and 6 multiplied together to make 6. But out of those two options, the one that's going to work is 2 and 3, because 2 and 3 also add together to make 5. So therefore, that is our example, and therefore, to finish it off, what you've got to do is once you've decided your two numbers, you've got to basically put them inside some double brackets, each individually in one of the brackets, and you're putting them with an x. So we have the x plus 2, and then we have an x plus 3. You can also check your answer at the end, and the way you do that is you multiply out the brackets again to see and check if you end up back with what you started with. So for instance, if I try to multiply x plus 2 times by x plus 3, I'm going to use a grid method to do that. Then hopefully we end up with x squared plus 5x plus 6. If I do, I know I did it correctly. If I don't, I know I've mucked up. So x times by x is x squared, 2 times by x is 2x, 3 times by x is 3x, 2 times by 3 is 6, and you'll notice from that we've got the x squared we wanted. We've got the 2x and the 3x combining to make the 5x that I wanted, and therefore I've also got the plus 6 on the end, and therefore we've got everything we wanted. Brilliant, so we factorised correctly. I'll also show another quick example where we look at how to deal with situations that have a negative number involved. And actually, the method doesn't really change. The only thing you've got to bear in mind is you do have to take account of whether it is a negative number when you're deciding what numbers multiply together to make the number on the end and add together to make the number in the middle. So for instance, in this case, we're looking for two numbers that multiply together to make positive 12. We're looking for two numbers that add together to make minus 8. That might make the question seem a lot more complicated, but you can use your knowledge of negative numbers to help narrow down what sort of numbers you're looking for. For instance, in this case, the numbers we're wanting have to multiply to make a positive number. And the only way you can get a positive number by multiplying numbers together is if you have two positive numbers or two negative numbers. So that's narrowing it down already. But then we're also needing those two numbers to add together to make a negative number. And two numbers can only add together to make a negative number if at least one of them is a negative number to begin with. So therefore, both of our numbers need to be negative. So therefore, we're thinking about numbers that multiply together to make 12. You've got a few options there, 4, 3, 1, 12, 2 and 6. And then we very quickly realize 2 and 6 are the option we want, because then minus 2 times by minus 6 will then lead to us having the minus 2 plus a minus 6 to get a minus 8. Brilliant. So therefore, it's going to factorise to x minus 2, x minus 6. Still just putting those two numbers inside the brackets. Okay, that's the most basic level of factorising, where you've just got one lot of x squared, no coefficient in front of that x squared, which is implying that you've got one lot of it. In other words, what happens if you have a number in front of that x squared? In other words, you've got a quadratic of the form ax squared plus bx plus c, where a, b, and c are all constants. You might notice that I've suspiciously written that a is bigger than 1 up here as a title, and that's because if a is not bigger than 1, there's a few other tricks you might want to consider, and that's what I'm going to be looking at in my second video based on factorising quadratics. So for the moment, this stuff is just for dealing with situations where it's just a number bigger than 1 in front of the x squared. Okay, what do you need to do? Well, you still need to think of two numbers, but there's a few extra conditions involved. You now need to be thinking of two numbers that multiply together to make the same value as, not just the number on the end. You want the two numbers to multiply together to make the same value as the a value, the number in front of the x squared, multiplied by the c value. You'll see what I mean when we get onto an example, but then those two numbers you choose also still have to add together to make that value that's in the middle, the coefficient of x. But once you've picked those two numbers, it doesn't end there. They don't just go inside some brackets, leaving you done. You do have to do some extra steps. You have to use those two numbers to help you split up that middle term in the algebra into two separate terms added together. Then you're then going to individually factorise the first and the second term, because now having split up the middle term, you have a total of 4 terms, and you just want to factorise the first and the second term in the expression you've got. separately factorise out the third and the fourth term, and then use all of that to gather all the stuff together to get two overall factors. Kind of difficult to describe this in words without showing you the steps with the actual algebra involved, so let's look at an example and make this all 10 times more clear. So we're factorising 6x squared plus 17x plus 5. So the first thing we need to do is multiply 6, the number that's the a, times by the number that's the c, which is positive 5. 6 times by 5 is 30. That's important because it now tells me I'm looking for two numbers that are going to multiply together to make positive 30. So that's this bit here. And then we're also looking for two numbers that add together to still make the term in the middle, the 17. So we got to think about that, think that for a while. I mean, you've got quite a few options, haven't you? You've got 30 and 1, 15 and 2, 3 and 10, 5 and 6. But after a bit of thought, you'll realise it's 15 and 2 are the ones that are going to work there. Okay, we have now decided the two numbers, but we're not going to just put them inside some brackets and call it a day. That isn't the end of the question. We are going to have to do these extra steps in order to be able to factorise this quadratic. We're going to use this 2 and 15 to help us split up the plus 17x term that's in the middle. So therefore, the plus 17x is now going to become plus 2x plus 15x. Still writing them in the middle instead of where the 17x was, but splitting up as these two separate terms now, corresponding to the two numbers we had found. Now I've chosen to write it as the 2x first, followed by the 15x. You could write it the other way around. You'll still get the correct answer in the end, but it just means your next couple of steps will look slightly different in the meantime. Okay, once you've done that, what we're going to do is treat these four terms that we now have as kind of like two pairs. We're going to first look at the first and the second term, and we're going to factorise them. By that, I mean we're going back to old school factorising, doing the situation where you're trying to factorise out the highest common factor. So you look at the first term and the second term, and you think, what's the biggest thing both of those things can be divided by? First, looking at the numbers, what's the biggest number that 6 and 2 can both be divided by? Well, the answer is 2. And then looking at the algebra, x squared and x, what's the biggest thing that both of those things can be divided by? Well, that's an x. So then we put some brackets and decide what's going to be left over when we divide both those things by 2x. So 6 divided by 2 is 3, x squared divided by x is x, and then 2 divided by 2 is 1, and then x divided by x is 1 as well. So we're just having a plus 1, and that's that bit done. We're now going to factorise out the third and the fourth term. And so then repeating that process, what's the biggest number that 15 and 5 can both be divided by? Well, the answer is 5. Positive 5 to be exact, so I'll put a plus 5. And then we've got an x, and then we've got no x's. So what's the biggest bit of algebra both those things can be divided by? Well, the answer is no algebra, because one of those things doesn't have any algebra to divide. So then we put the big brackets, and then what's going to be left over when we divide by 5? Well, 15 divided by 5 is positive 3. And then x, well, there's no algebra we're dividing by. And then we've got 5 divided by 5, which is positive 1. Something you'll notice if you've done this step correctly, you should end up with the same thing appearing in the brackets here and here. If they're not appearing the same, you haven't fully factorised out as much as you possibly could, or you've made a mistake in the factorising, or a mistake choosing the numbers even earlier. So once we've done this, the final thing we need to do is gather the things together into just two distinct different brackets. It's very clear from this that one of the pairs of brackets is going to be a 3x plus 1. You can see it in more than one place, so it's clear that's going to be one of the brackets. But then the other pair of brackets is decided by what's not in the brackets. You see we've got a 2x and a plus 5, and those are the things that then form the other bracket. So 2x plus 5 is our other bracket, and there you go. We're done. Nice. So 3 just fine examples to either test your skills if you want to have a go at practicing this stuff yourself. I'm going to give you 5 seconds to pause the video if you want to have a go at them. I'm also then going to go through them, so then you can either have these as extra examples if you want extra examples, or just work solutions in case you've tried and you want to check your answer. So this first one, it's only got one lot of x squared, so simply we're looking for two numbers that multiply together to make 35 and adds together to make 12. So we think about the numbers for 35. There aren't many, luckily, so you very quickly realize it's 7 and 5. Nice, so therefore in brackets it'd be x plus 5, x plus 7, or the other way around, x plus 7 times by x plus 5, doesn't matter which way round you wrote them. 4x squared plus 15x plus 14. Ooh, this time we can see there is a number in front of the x squared. So first of all, I'm going to need to multiply this number by this number. So that's 4 times 14. That will get you 56. So therefore, we're looking for two numbers that multiply together to make 56, but they also must add together to make 15. Now, this is a test of your times tables. 56, hopefully you'll recognize as being 7 times by 8, which is luckily the numbers we want to choose, because 7 plus 8 is also 15. Okay, so we can now use our two numbers to split up that middle term in the quadratic. So I'm going to rewrite the quadratic as 4x squared plus 7x plus 8x plus 14. And therefore I can factorize the first and the second term first of all. There's not going to be any numbers we can divide 4 and 7 both by. Well, technically there is, it's 1, but therefore that's a silly thing to factorize out. And then what's the algebra we can factorize out? Well, x squared and x are both divisible by an x. So that's what we're going to have to factorize out. 4 divided by 1 is 4. X squared divided by an x is an x. 7 divided by 1 is still 7. And then the x divided by the x means there's now no algebra there. And then factorizing out the third and the fourth term, well, the biggest number, 8 and 14, are both divisible by is plus 2. So I'm going to write that there. And then inside, we're not going to be able to factorize any algebra because the 14 has no algebra. And therefore, 8 divided by 2 is 4. X divided by no algebra is x. 14 divided by 2 is positive 7. And then there's no algebra to deal with. And we are already feeling very confident there's a 4x plus 7 in both places. And so therefore, the final answer is going to be 4x plus 7 and x plus 2. On to the third example. We start by multiplying the first and the last term together. Watch out, that last term is a minus 8. So it's 3 times by minus 8, which would be minus 24. We have, therefore, the challenge of having to look for two numbers that multiply together to make minus 24, but still got to add to make positive 2. Now, things to bear in mind, if you have two numbers that multiply together to make a negative number, one's got to be positive, the other's got to be negative. But if they're adding together to make a positive number, that's important because it means the positive number has got to be bigger than the negative number in terms of size. So therefore, in terms of before you put the negative sign in front of it. So therefore, thinking about that, we want, therefore, effectively two numbers multiply together to make 24, but have a difference of 2. So therefore, you have to think about that, and you realize 6 and 4 fit the bill. Therefore, that means it's going to be positive 6 and minus 4, because then we have the positive and the negative to make the negative 24 overall. But then also 6 plus minus 4, that's the same as doing 6 take away 4, which we get the positive 2. Right then, we can now do the splitting up. So that will get us 3x squared plus 6x minus 4x minus 8. Okay. And now we can do the factorizing, the first and the second term. We can factorize a 3 out of both of them. We can factorize an x out of both of them. That will leave us 3 divided by 3, which is 1. X squared divided by an x is just x, so it's 1 lot of x is the first thing inside the brackets. We'll have 6 divided by 3, which is 2. X divided by x will therefore mean we've got no other algebra. And minus 4x minus 8, we're also going to factorize. What's the biggest number we can divide both of them by? Well, we can divide both of them by 4, but actually we can go further and divide both of them by minus 4. The reason I can already tell I want to do that is I know my brackets for the second time have also got to end up with an x plus 2 in the end, so therefore we want a positive x inside them. So if I hadn't factorized that minus number as well, we won't end up with the same thing inside both of these pairs of brackets. So therefore it is -4, and therefore basically as a sort of little trick, always factorize the negative out. If there's a negative sign in front, factorize that out the front as well. Even if it's only one of them. In this case, both of them were negative signs, but even if it was just the first term that was negative, factorize the negative sign out of both of them. Okay, -4 divided by -4 is 1. X divided by no algebra is just an X. -8 divided by -4 is +2. Okay, do watch out for that. And then therefore the final answer is x plus 2 times by 3x minus 4. That's one that you might be a bit unsure of, so that is one where you might be very, very recommended to try quickly multiplying the brackets to check it comes to the correct answer. That is factorising quadratics, at least the basics. We'll have another video looking at some special tricks for more specific scenarios, namely what happens if a is not bigger than 1, and I will therefore see you in that video. Goodbye.